Okay, so here's a little bit from exercise 11.2. In question 1, we need to find the locus of P, which is always 1 unit from 0, 0. So if that's talking about a distance, so I'm using my distance formula, which is here, and I'm saying the distance between P and 0, 0 is 1, so that's why I'm saying the distance is 1. I've written, by the way, the distance formula in terms of its squared form, so I don't have to write square roots all the time. So there's distance, 1, x minus x naught, so x minus x naught goes there, and then y minus y naught goes there. Okay, and then that's 1 equals x squared plus y squared. So in number 2, we're always 9 units from A. So my 9 goes in here. This is where 9 goes for my distance. And it gets squared and becomes 81. Then I'm going x2. I've decided that x2 is the x and y2 is the y, right? I'm going to use different colours. I'll go green. And these ones here, I suppose these ones here, see these ones? They go in there and there. So once you sub that in, you can get an equation. Now in the back of the book, they don't stop there, they keep going, they get it in its general form. So that's what you can do. You can expand out the brackets, take it all over to one side, and then come up with this answer there. Number 3. Once again, it's a distance. It's always 2 units from 5 minus 2, so I've set it up, so it is. Once again, I haven't expanded that out, but if we did expand it out, we could get x squared minus 10x plus 25 there. Here we'd get y squared plus 4y plus 4, and 4 still on that side, and then you take everything all over to one side. So we're going to get x squared minus 10x plus y squared plus 4y, and then that's going to be plus 25 when I take 4 off both sides, and that gives me a 0 there. Okay, so that's it probably in the back of the book. Number 4, we're going to be always equidistant from these 2 points, so P's in the middle of them, all right? But it doesn't have to be the shortest distance between those 2 points. It could be anywhere. So like you could have 2 points here. Let's say that's A and B. P could be sure right there, but P could also be at B out here. See, that's still equidistant. So it could be anywhere like that. So you can see this is tracking out a line, because anywhere I go that's equidistant, it's going to sit on a line. So that's my prediction, that it's going to sit on a line. So let's see how we go. So let's do the distance formula between P and A and P and B. I've done it in the squared form of the distance formula, so I don't have to write square roots. And because it is the distances that are equal, I then have to square both sides for me to be able to use the format with the squareds. So then I just sub straight in, expand out, and then take everything over to one side, equal to 0, and yeah, it is a straight line, because straight lines are of the form ax plus by plus c equals 0. Okay, next one. Here we go, equidistant again, so expect a straight line. Same as the last one. And there's all the working out. And your final answer is down there. Hope that helps.